Hi, in this video I'll be discussing memory, more specifically encoding, storage, and retrieval. Okay, to start, what is memory exactly? Like many topics in psychology, like intelligence, it's a bit tricky to define. So to put simply, it's where the mind stores and retrieves information. But how is information stored in the first place? Let's talk about that for a minute. Essentially, information is stored via our senses, a process known as encoding. It allows sensory information, such as auditory and visual information, to be transformed in a way that allows it to enter memory. There are several ways to encode information, but for now, I'll only mention the three that you'll likely hear about most often. There's semantic encoding, which is information encoded that has a particular meaning to it, like important dates, word definitions, and places on a map. It is thought that semantic information is a lot stronger when we attach meaning and emotion to it. We can also process and encode sounds through acoustic encoding, which can involve using what is known as the inner voice, which I'm sure many of us use, including myself, to recite information to strengthen memory before an exam, for instance. Auditory information is stored temporarily in echoic memory, and unless this information is strengthened, then it will normally last a few seconds at best. We can also use visual encoding, where we process and encode visual information and it is temporarily stored in iconic memory. And similar to echoic memory, we will generally forget visual information in seconds unless it's strengthened. I'll be covering the topic of forgetting in a separate video because there's quite a few theories to cover. So now let's turn to storage. When we think about storing encoded information, it's not as if it gets automatically transferred to long-term memory, and, as we've already established, we tend to forget things and that's normal. Storage involves three memory stores: sensory memory, short-term memory, and long-term memory. Sensory memory is basically what we've just covered, where all kinds of sensory information is taken from our environment, which is typically forgotten within moments, unless we make an effort to remember such information. In this sense, sensory memory can be thought of as a necessary prerequisite for information to travel to short-term memory, which can hold information for a bit longer than sensory memory. When we think about short-term memory, we think about capacity, duration, and coding. This also applies to long-term memory. Although psychologists Hermann Ebbinghaus and Wilhelm Wundt were the first to think of short-term memory as being limited to 6 or 7 pieces of information, it was Miller in 1956 who came up with what is known as chunking, which is a good way to basically expand the limited capacity of short-term memory, which Miller thought to be limited to 7, give or take 2 items of information. This can be done by taking large amounts of information and reducing it to smaller ones. Say if you're asked to memorize this random sequence of numbers. Looks intimidating at first, with 20 individual numbers, but what if we use chunking to efficiently remember it all? We can try reducing this large piece of information into 5 separate numbers, each with 4 digits. As you can see, we've just separated this large 20-digit number into 5 separate chunks, which is within our limited capacity to remember information. And to make things easier, you can remember them as dates, and the fact that they're in ascending order. When it comes to duration in short-term memory, it is thought that duration is pretty much determined by the amount of rehearsal you do to information. The more you rehearse, the longer the duration. As for the capacity and duration of long-term memory, it's generally accepted that long-term memory has an unlimited capacity, and information can last in long-term memory anywhere between a couple of minutes to several years. What would be stored in long-term memory include where we live, life goals, language, motor skills, and so on. When it comes to coding, it would seem that short and long-term memory use different types of coding. For short-term memory, a study by Conrad in 1964 found that short-term memory is mainly coded according to its sound. This was done by having participants try to remember a list of 6 consonants, each of which was only seen for a split second, and they were then asked to write them down. It was found that mistakes were made when letters sounded the same, for example, B being mixed with P and V, while there were very few instances where S was mixed up with P. For long-term memory, the coding seems to be mainly semantic. A study by Badley in 1966 found that participants could recall more acoustically similar words than dissimilar words, which supports Conrad's findings with acoustic coding. However, when testing for long-term memory, it was found that semantically similar words were recalled while the rest had virtually no effect, which suggests that long-term memory uses semantic coding. But considering the nature of long-term memory, does it also use other types of coding? I would say yes, because if you think of a memorable event from years ago, you're likely able to visualize it. If you've ever had an amazing meal, you're likely able to remember what it smells and tastes like. And your favorite songs? you're likely to know what it sounds like. So not only is long-term memory unlimited and long-lasting, but it's also flexible. As for retrieval, that is, recovering information from long-term memory, there are several ways this can be done, but for now I'll mention two common ways. First is through recognition, where we figure out whether we've encountered a piece of information before. For instance, Standing in 1973 showed participants slides of around 20 pictures or words for 5 seconds at 3-minute intervals. 2 days later, the slides were shown in twos, one of them from the original slides and the other was a completely new one. Many of the participants chose the correct slide, which they found to be more similar to them, and similar results were found when the number of images or words increased. Lastly is recall, which involves consciously searching memory for pieces of information. A good example of this would be essay questions in exams, where information can be recalled according to the order it was studied or any order it was studied. So that's it for now. Let me know if you would like me to discuss something in more detail from this video or any video from this series so far. Next I'll be covering memory models. Thanks for watching and I'll see you then.